Okay, so again, good morning. So ang gagawin natin ngayon is probability. So I'll leave it up to you guys para basahin yung modules on your own. So what we'll be doing right now is more of parang practice lang, no, on how we can use spreadsheet programs para ma-solve yung mga probability, no. And may ilan dito na problems na hindi kailangan ng actually ng ano, no, ng spreadsheet program. Pwede ngang calculator lang gamitin mo. Pero it's just more convenient if you use the calculator, the spreadsheet programs, no. So let's start with itong first problem natin. So I'm assuming na at least some of you have already read the module, no. Tapos sana masundan niyo pa rin yung discussion, no, kahit hindi ko na i-discuss lahat ng mga specific na formulas na gagamitin natin today. Okay? So we start with this one, and meron daw tayong 5-digit number that is to be formed using digits 1, 3, 5, 7, and 9 without repeating any of them. Then what is the sum of all such possible numbers? Okay? So pagka tiningnan nyo siya, um, if you've read the modules, no, there is no one equation na para mag-fit sa description, no? So hindi siya pasok dun sa hypergeometric function, binomial function, sa Poisson function. Hindi rin siya combination problem, hindi rin siya permutation problem, no. So or pwedeng maging combination siya of a few um of those methodologies, no, or yung mga formulas na yun. Pero hindi siya iisa lang yung formula na gagamitin natin. So for in this particular case, it's always just easier na ano, no, that you use a brute force method, no. By the way, just so I can get a good grasp, no, kung nasaan na kayo sa triple ME14, no? Meron na ba nagbasa ng probability module? And please be honest para at least alam ko kung paano ko ano, no, i-go about tong lesson na to. So, maraming no. Okay. So, mukhang kailangan mag-start tayo from, sige, mukhang hindi pala mag-work kung diretso tayo sa problems. So, maybe we can start with the modules themselves, no? So, let me just bukas tayo ng edge. Okay, probability. Up, up, up. Right. Okay. So probability is, and I'll just skip ahead to the important parts dito, no. So probability is the likelihood of something to occur, no. So it's usually given by this equation. So we have P of A, where A is an event. So we call this as the probability of event A occurring. And this is equal to the number of ways which event A can occur divided by the total number of possible outcomes. Okay. So usually it's a fraction, no? So or a decimal value from 0 to 1. And 0 indicates that this is there is an impossibility, while 1 indicates that there is a certainty of that event A of occurring. Okay. So we won't go into this, no, pero yung pinaka siguro ano natin, one of the important na concepts na we need to understand in probability is itong multiplication rule, no. So if we have, for example, an operation, and yung operation na yun can be performed in n1 ways, And for each of these ways, itong N1 ways, you can also perform a second operation in N2 ways. Then the two operations can be performed together in N1 times N2 ways. Okay? So kung meron kang kung kumbaga multiple na ways na to, then you just keep multiplying it. No? So that's saying na N1 times N2 times N3 dot 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 times NK. Yun yung kumbaga sample space na pwedeng mag-occur yung isang event na yun. Okay, so this is important because if you know the I don't know the number of ways that a certain event or a certain operation can be done, then we can also relate this to the number of to the probability of that particular operation um, can be done, no? Kasi if you notice na yung bottom part kasi natin is the total possible number of ways, no? So if you, for example, no, sorry, yung top part is the number of ways event A can be occurred. So kung parang dinivide mo lang siya by the total number of possible outcomes, then therefore kung ito yung N1 ways, tapos meron kang N2 ways, then the probability is also multiplicative in nature, no? And this is for things that are done together, no? So kumbaga ang key indicator dito is the word and, no? So whenever you see a problem that has the word and, usually you use the multiplication rule. So kailangan mong i-multiply siya. So pwede siyang kung the question could be how many number of ways can this be done with given that this is ganyan ganyan ganyan. So pag ganyan how many number of ways, then you just multiply the parang number of ways dun sa yung event A na yon. Pagka sinabi naman probability, then you multiply the probabilities. You always take into account yung language for which the problem is set, no? Kasi it will give you a big idea kung paano siya iso-solve. And ang tip ko dito is if you see the word and, usually you multiply. Tapos if you see the word or, kung or naman siya, then you will have to do a addition na ano, no. So although there are many ways pa, no, kasi if you're familiar with saan bang math to tinuturo, yung mga union, intersection, na familiar ba kayo nun or nakapag philo 11 na ba kayo or any sort of logic na course? Na Shane says meron naman silang na-tackle to sa math, no. So there are more complicated cases, no? For example, yung mga mutual exclusive na events. So, or tsaka merong mga events that are not mutually exclusive. So, mag-iiba yung, kumbaga, no, yung calculation natin. Pero in general, dito sa MMME14, we'll be usually dealing with yung two types lang, no? Yung and na events, yung what is the probability of this occurring and this occurring. So, yun. And also, yung what is the probability that this occurs, event A occurs, or event B occurs. Usually, yung mga simple cases lang na gano'n, no? And there is an assumption na mutually exclusive yung two events na yun. Although, just to be accurate, no, for every problem na ibibigay namin dito, i-state namin na yung mutual exclusivity ng events, no? If you are not sure kung mutual exclusive ba yung events, kung kumbaga meron pa ba siyang union or meron pa ba siyang intersection, then you can ask us. Pero in most cases, it is safe to assume na yung lahat ng events na ibibigay namin is, unless otherwise specified, no, lahat ng events na i-state namin is mutually exclusive. Okay? So later mag-make sense siguro siya, no? Okay? So ito, we have, sige, okay na tayo dito. Sige. So I'll leave this to you guys to, I don't know, to work on your own. Pero ito, let's try to look at simple examples lang muna. So for example, if a coin is tossed and a die is rolled, find the number of possible outcomes. So parang ang sinasabi dito is ano yung number of ways na pwede mong or the number of possible outcomes sa dalawang operation na to. So the first operation is a coin being tossed. The second operation is the die being rolled. Okay? So Sa first operation natin is yung heads or tails. Tama? Kasi it's a coin toss. So you can either have heads or tails. So there are two possible outcomes. While the number of possible outcomes naman when you roll a die is 6 kasi may 6 sides tayo sa ano no, sa die no. So if you do the multiplication rule, then the number of possible outcomes for these two operations to be done together is 2 times 6, which is equal to 12. Okay, so there are 12 possible ways. Now, if I ask you what is the probability that I get a uh, heads on the coin toss and, for example, number 1 on the roll die. Parang ganun. So in this time, instead of asking for the number of outcomes or the number of ways, ang tinatanong ko is probability na. So kung probability na siya, we will use something like, wait lang let me, ano nga yun? Pen tablet. Monitor 1. Okay. Sunod lang. So, pagka ganun, if we do something like that, no? So let's change the problem. So anong probability pag itong toss natin is ang lumabas dito is head. Tapos ang lumabas dito is the face 1. No? Yun yung results. So pagka ganun, ang probability na mag-head tayo is just heads. That's one outcome, no? Sa sample space ng coin toss, there is only one head na pwedeng outcome. Tama? So it's either head or tail. So therefore, it's 1 over the total number of ways or total number of possible outcomes is 2. So you have 1/2. So yun yung probability of getting a head, no? Tapos for the ano naman, roll die, yung sa pag-roll ng die, meron tayong 6 na possible outcomes. Tapos one of those is the 1, no? So that's 1. And yung 6 possible outcomes is yun yung denominator natin kasi yun yung total number of probability. So that's 1/2 and 1/6. So if you want to get the probability na yung makuha natin is a head and a 1, then we just do, again, multiplication rule pa rin. 1 over 2 times 1 over 6, which gives us 1 over 12. So yun yung, eto na yung probability natin. Okay? So, in probability, no, medyo intimately connected yung possible outcomes and the probability, no. So most of the problems will be stated this way, what is the probability, but some problems will also be stated this way, no. Ano yung parang total number of ways that they can be arranged, parang ganun. So they all fall in the realm of probability, no, kasi understanding the number of ways is also in a way understanding the probability. Okay? So, let's go with... So, malinaw ba 'yon? O okay ba tayo? Parang nasusundan pa naman, no? Yung basics of probability. Alright, sige. That's good. Thank you for the feedback. So, ano tayo? I think that would be enough. Hindi pa siya enough, no, para mag-exercise tayo. So, let's go. Let's continue with the discussion, no. So, again, class, I'm just skimming through this module, no, kasi ang design naman ng modules na to is for you to work on your own pace, no. So you can just review the modules, read it on your own time, tapos try nyong i-understand siya, no. So what I'm just trying to do here in the synchronous session is to give you a parang overall, parang ano lang, no, ano ba tawag doon, parang rapid fire lang na understanding nitong module na to. Tapos and gusto ko sana na ipakita sa inyo yung actual na mga problems tapos how we solve them using Excel, no. Okay? So let's just say ito isang example problem na to, no, kasi this is a good problem, no. And for this problem we will be using what we call as the brute force method, no. So in some cases there are cases talaga na parang mahirap na ma-imagine yung problem or mahirap na i-set up yung equations ng isang problem using yung mga different na ituturong methodologies dito, no. And sometimes it's just easier to do brute force method, no? Lalo na pag hindi naman ganun kadaming numbers yung involved, no? But also in the same vein, no, meron din mga problems na hindi mo kayang i-brute force, no? Or kaya i-brute force pero sobrang tagal bago ma-solve mo siya using the brute force method. So, you need to do a balance, no? Kailangan mong maintindihan or it takes a lot of practice pero sometimes or this is a skill that you need to know, no, especially in terms of this topic, no, itong probability. You need to understand kung kailan pinaka-effective gumamit ng brute force method or kailan gumamit ng mga formula natin. Okay? So, let's try to do this. Meron daw tayong an apple, a banana, an orange, and a mango, and also guava. And how many ways can we arrange these 5 fruits? Okay? So the way we do it is, ang simplest way is we do something like this, no? So, kunwari, this is just an representation of the spaces na pwede natin i-occupy, no? So for example, if we arrange it this way, so this is 1, 2, 3, 4, 5. Tama? So ito yung kumbaga, let's just imagine a table to. Tapos dito natin i-arrange yung mga fruits na to. Okay? So the brute force method is just simply looking at the space, tapos tinitingnan natin kung ilan yung ways na pwede natin ilagay yung space na yun, or pwede natin i-occupy yung particular space na to, itong mga blanks na to. Okay? So if we start with 5 fruits, then there are 5 ways where we can place the 5 fruits, no? So there are 5 ways we can do that. So pwedeng apple yung una kong nilagay, banana, orange, mango, or guava. Tama? Now, once you have decided on placing that first fruit here, yung sa second spot, bawas na yung number of ways na pwede mong i-arrange yung next fruit, no? Tama? Kasi kumbaga kung if for example nilagay mo na yung apple dito sa first space natin, and then dito 4 na lang yung natitira, which is yung banana, orange, mango, and guava. Tama? So kung 4 na lang, then there is only 4 ways that you can do this space. So kung 4 na dito, then there is 3 ways dito, 2 ways dito, and 1 way dito. Now to get the total number of ways that we can arrange this, then it's just as simple as applying the multiplication rule, no? So again, yung multiplication rule, if you have one operation that can be done in 1 ways, tapos meron kang another operation that can be done in 2 ways, and so on and so forth until nk ways, then yung yung number of ways that we can do this, all of these operations together, is just simply by multiplying each of the number of ways. So in this case, multiply lang natin si 5 times 4 times 3 times 2 times 1, and that will give us 120 ways. So there are 120 ways na pwede natin i-arrange itong fruit na to. Okay? Now, what is the probability na ang lumabas is apple, kunwari apple, orange, banana, mango, and guava. Kunwari ganyan. Kung gusto ko specific arrangement, ano yung probability na ito yung makuha kong arrangement if I were to do this operation at random, no? So this is, di ba, there are 120 ways that we can do this. And this is just only one of those possible ways na magagawa ko to. Tama? So if that's the case, then the probability of achieving this type of pattern is just 1 over 120. Tama? So I hope that makes sense, no? So that's just a simple problem where we can use the brute force method. So and the brute force method employs the multiplication rule, no? Right? And merong magandang comment si Shane dito, no? This is actually a factorial, no? So this is a 5 factorial. And you'll notice later na when we do combinations and permutations, and some of you might be familiar with this, I don't know, 2 values right here. And if you look at your calculators, makikita nyo rin to, no? Yung NCR and PR. So if you look at the, itong mga equations na to, they actually involve a lot of factorial na na operations. Okay? So let's, speaking of permutations, no? This is actually our next slide. So a permutation is an arrangement of all or part of a set of objects, no? So let's consider the letters A, B, and C. Ano yung mga possible permutations niya? So we can actually list them down, no? Tapos, if we list them down, then we can actually get the number of ways na pwede natin ma-achieve yun. So you can do ABC, ACB, and this is actually a brute force method na rin, no? ABC, ACB, BAC, BCA, CAB, and CBA. And you can't have any other list, no? If you add more, it's just a repeat of whatever you have already written. Okay, so in this manner, there is 6 permutations na pwede natin magawa sa ano, no, sa etong arrangement of the letter ABC. Okay, and the yung mga statisticians na compute na nila kung ano yung or nagawa na nila ng ano, no, ng equation kung paano to mako-compute yung mga arrangements na to. Okay? So we can have this as n factorial lang. So ito same method na ginamit natin kanina, no? So dito there are 3 letters available to us. Then there are 2 letters available in the next space, and there is only 1 letter available in the last space, no? Pwede rin baliktad, no? So if you can also start from here, no? So 3 available dito, 2 available dito, 1 available dito. Doesn't really matter, no? Okay? So a permutation, let's consider this is a ano, no, unique permutation kasi this is the number of arrangement of 3 letters taken 3 at a time. Okay? So meaning meron tayong 3 available letters, tapos we are permutating, taking all of those letters at a time, no? So if we were to write this down, parang 3p3 yung ano natin to. Notation natin dito, no? So that's NPR. So we call that as this is 3. So ang term natin is 3 taken, usually stated this way, no? Or read it this way. 3 taken 3 at a time. Kailan natin siya binabasa. Okay? Now there are cases wherein, for example, we have 4 letters. Kunwari ito A, B, C, and D. Tapos pero gusto natin makuha yung ano yung mga permutations ng yung 2-letter combinations nito, kumbaga, or 2-letter permutations nito. So pag ganoon, hindi na siya ano, no. Kasi ang ililista na lang natin is kunwari A, B, AC, AD, and you can do this, no? Parang pwede mong ilista siya. So you do AB, AC, AD, tapos you do B, A, B, C, B, D, etc. etc. Tama? You can do a brute force method. Pwede mo exhaust lahat ng list. Problema dito is baka may ma-miss out ka, no, na combination or permutation. Tapos prone to error siya, itong brute force method. So the way we do this is we can use a permutation equation. No? And the permutation equation is given by this equation right here. It's NPR is equal to, and this is read as the number of permutation n, the number of permutations of n distinct objects taken r at a time, or simply just itong n taken r at a time. Okay? So we do meron tayong n objects, no, n, and in this case we have 4 objects and we want to take it 2 at a time. So 4 taken 2 at a time yung sinusolve natin dito. So you can do this equation. Pwede rin sa calculators nyo, and let me just show my calculator. Wait lang, class. Utility. Saan ko pwede ilagay ito? Dito? Okay lang ba dito sa gilid? Nakikita naman yung calculator? Okay, kita naman. So, lagay ko na lang sa bottom corner, no? Para for those who want or who opts to use calculators instead of a spreadsheet, you can use the calculator itself. No? So, if you look at this, meron actually sa calculator, no? And it's, where is it located? NCR. NPR. Nandito siya, no? So, dito sa itong naka-colored yellow siya sa taas ng multiplication and sa taas ng division, no? So, meron tayong maliit na NPR dito. Tapos, meron din maliit na NCR dito. Hindi ko alam kung nakikita nyo ba yung mouse ko. Mukhang hindi nyo ata nakikita, no? Hindi nyo nga nakikita. Pero anyway, if you look at ito sa taas ng multiplication sign at taas ng division sign, meron siyang, and hopefully we have the same calculator, no? Kasi ito yung pinaka-common na calculator. Although, meron natang bagong calculators ngayon, no? So, you might want to try to find it. Pero in my calculator dito sa virtual calculator ko, I should say, is nasa taas siya ng multiplication sign and nasa taas siya ng division sign, no? Yung NPR and NCR. So, we can try to input that, no? So, let's take 4. That's 4. Taken 2 at a time. So, I press the shift and press the multiplication button. So, that gives me 4p. And I'm taking it 2 at a time. So it should give me 12. Okay? So 4 taken 2 at a time is equal to 12. Pwede rin, nang gamitin ko is actually Excel, no? So if I shift to Excel, let me punta tayo sa Excel. Wait, bakit hindi siya nakikita? Excel. Ayan. Pag Excel naman, you do permute, no? Ito yung equation natin, permute. By the way, do you see the pop-up? May pop-up pa kayo nakikita? Wala. Mas maganda pala kung dito tayo. Ito pala yung issue sa OBS. So, let's do ito. Ito, hopefully mas nakikita na siya, no? So, if I do equals permute, yan, nakikita nyo yung pop-up, no? May parang tooltip na lumalabas. Usually, when we do Excel equations, no, meron siyang mga tooltips na lumalabas sa mga common formulas na ginagamit natin pagka when we type certain letters. No? So for example, if I do average, kahit ave pa lang nilalagay ko, meron na agad lumalabas, no. So ang shortcut dito, and probably na-explain ko to sa sa previous video if napanood niyo siya, kaso hindi yata lumalabas yung tooltip. So explain ko na lang din ulit. So if I do, for example, permute, I can actually kahit perm PERM pa lang yung sinelect ko, tapos kung nakita nyo naka-highlight na yung permute, pwede rin I can go up and down. So if I press the down, up and down arrow keys, pwede kong i-select siya, no? So para ma-select ko siya, kunwari naka-permute na siya, to select it, just press tab, no? So if you press tab, isa-select niya yung autofill na yun, kumbaga. So let's do, for example, equals average, kunwari. Pag tinab ko siya, lalabas siya ng ganyan. So this becomes extremely helpful, no, pag kunwari paulit-ulit yung ginagamit yung isang equation, mas mabilis na siyang ma-fill out, no? So let's do permute again. Permute. So press tab. Tapos yung first number is actually the n value or the number of objects. So in this case it's 4. Tapos and Excel has this ganito yung yung syntax na ginagamit ng Excel. So it's equals the name of the formula that you're using, open parenthesis, and enclosed in the parenthesis is the arguments, no? Yung arguments na kailangan niya para magawa yung equations natin. So in this case, si permute has 2 arguments, no? And you need to fill out all of those arguments para mag-work yung formula natin. So some have optional na arguments. So let's see, I think stdev. .s wala siyang VLOOKUP. Kunwari, let's do VLOOKUP, no? No, sorry. Lookup na lang. Yan. Kunwari itong lookup, you will notice na merong itong naka-bracket, no? Usually, when you see a bracket, ang ibig sabihin nun is an optional na argument. Itong square brackets na to. So later you figure out na some formulas have optional na na arguments na hindi kailangan i-fill out. So ang kailangan mo lang is actually itong first and second. Yun yung necessary para hindi siya mag-error, no? Anyway, let's do permute. And the number of arguments is 4. The number of objects, I mean, is 4. Tapos yung we take it 2 at a time, no? So itong number chosen na to is just the number of kumbaga how many times we take the number of objects, no? Okay? So that's 4 taken 2 at a time, and it should give us 12, no? Same as dun sa lumabas kanina, no? Dun sa natin equation. So okay tayo dyan. Okay, so balik na tayo. So, I've shown you two ways, no? And kayo na bahala kung ano yung mas komportable kayo. Pero ako, suggestion ko kasi we'll be dealing, lalo na pagka sa, no, sa future lessons natin, we'll be dealing a lot with Excel. So, I suggest just familiarizing yourself with Excel na as early as now, no? Para mas madali siya. Although, di hamak mas madali gumamit ng calculator kasi hawak niyo siya, mas mabilis siyang i-type. So, it's up to you guys, no, kung ano yung mas gusto nyong gamitin. Okay? Now, dito sa another type of parang yung consideration of the number of ways we can combine certain or we can arrange certain certain objects is yung tinatawag na combination, no. So combination, and to explain this, mas maganda kung ipakita ko dito sa list na ginawa natin, no. So dun sa parang short itong parang truncated list na ginawa ko, no. Meron akong nilista na AB, and this is actually if in some sense, no, same lang din siya sa BA, no. Kumbaga na magkaiba lang yung order nila. So there are cases wherein kumbaga in the real world hindi nagmamatter itong order niya. Sa kunwari, if I were to group you guys into certain groupings kunwari. So for example, I have a list of students. So I have student A, student B, student C, student D. And I want to group them into groups of 2. Pagka gumawa ko ng parang permutation ito, I will end up with something like AB, tapos meron din akong BA. Pero, if groups to, these are actually the same groups, tama? Kasi this is a group where I have students A and B together. And this is another group which I have student B and student A together. Magkaiba lang yung arrangement niya. So in that sense, hindi nag-make or kung ganong scenario siya, no, hindi nag-make sense na permutation yung gamitin ko. Kasi order does not matter. So if order does not matter, combination yung mas appropriate dito. Okay? So yun yung siguro pinaka takeaway nyo dito, no? Dito sa permutation, order matters. Order matters. Tapos dito, order does not matter. So pagka ganito, it will be up to you guys kasi hindi explicitly sasabihin sa problem, no? Hindi naman sasabihin ng problem na use a combination formula to find the ganito ganyan. So kailangan yung ma-discern kung if it's a combination problem or it's a permutation problem depending on what is being asked and how the data is being presented to you guys. Okay? So let's look at this example. Now, there are 9 students in a particular lab class. How many distinct ways are there to form a group of 3? Okay? So pagka ganyan, no, it makes sense na group of 3. So ibig sabihin, if I do ABC, walang pinagkaiba yun sa BAC, hindi din siya distinct from CBA, kunwari. Tama? It's all the same. These are the same groups. So pag ganun, order does not matter and therefore I use a combination equation. So the combination equation, you can use this formula. Pero suggestion ko, just use the calculator or the Excel. So if you use Excel, we can have, and I'm doing Excel right now, no? So, no, sorry, I'm doing the calculator. So I'm pressing, I have 9 students and I want to have a combination taken 3 at a time. So I just do 9, shift, itong division symbol. So I get 9C and I'm taking 3 at a time. So 9CR siya. So 9CR gives me 84, which is the same dito sa na nakuha natin dito, no? So nakuha yung calculator. So 9CR, and we can also do that in Excel as well, no? So if you do Excel, it's equals combine naman yung niya. So again, ito, kahit comb lang yung tinype ko, pwede kong i-tab na. So if I press tab, it will select kung ano yung naka-highlight in blue. So if I do equals combine and I have 9 objects taken 3 at a time. So if I press enter, I should get 84, same value, no? So again, up to you guys kung ano yung mas komportable kayo. Okay? So that's permutation and combination. Denoted by ito, mamaya mag-ano tayo ng mga problems, no? Okay? So, yun yung mga simple cases, yung permutations and combinations. But there are more complicated cases now that involves a what we call as a random variable, no? And I'll leave it to you guys to understand what random variables are. Although hindi naman siya ganun ka-importante sa lesson, pero if you want to know, kumbaga, if you want to have a deeper appreciation kung bakit importante si probability to statistics, then you need to understand what random variables are, no? Okay? So, there are two types of random variables. Meron tayong tinatawag na discrete random variables, as meron din tayong continuous random variables. So, ang difference lang nila is sa discrete, may finite number of elements ka, no? So, for example, these are finite number of elements. And this is an example of a sample space where there is infinite number of elements. So, for example, kasi this is a picture of parang growth ng isang child, no? So, for example, from this point to this point, there are infinite number of kumbaga division sa time, no, na pwede tayong kumuha ng snapshot kumbaga. So pag ganun, infinite siya, that is a continuous random variable. Pag discrete naman, kumbaga kaya mo ma-distinguish each element from another. So finite siya. So yung mga kunwari cards, dice, and usually ganito yung examples na binibigay sa probability, no, kasi yun yung mas kumbaga mas na-appreciate ng mga students, kumbaga. Yung mga dice, cards, toss coin, mga ganon. Yun yung usual example. Hindi naman dahil sa gamblers yung triple M, no? Yun lang talaga yung best way to explain probability, no? Yung mga dice and cards and coin cost. And actually, napanood nyo yung video about probability. Yung sinend ko ba yun? Hindi ko na-send. Yung sinabi ko sa inyo na YouTube video. Meron din ako isang video pala na parang sige, link ko na lang doon sa ano natin, no, na sa yung hindi ko pala na-send. Thank you, Renee, for the ano, no, the feedback. Hindi ko pala na-send, pero i-send ko na lang, i-send ko doon sa ano natin, yung sa ang tawag dito, yung Google Chat groups natin, may links tayo doon, no. Lagay ako ng links ng mga parang cool YouTube videos na pwede nyo panoorin na ko mas ma-appreciate nyo siya, no. Okay? So, meron ding about probability kasi na ko maganda siyang ano video, no, for appreciation. Right? So, dito magbibigay ako ng isang example of or magbibigay ako ng 3 more probability distributions, and these are for discrete probability distributions, no? So which means na meron tayong so hindi infinite yung number of elements natin, kumbaga discrete siya, so kaya natin mabilang siya. And these discrete probability distributions are binomial, hypergeometric, and Poisson. Okay? So, usually, discrete siya kasi ang important dito is yung term na success and failure, no? So, kumbaga, meron tayong term na success, meron ding failure. Okay? So, ito lang yung 2 outcomes na gusto natin malaman, no? O from this discrete probability distributions, no? So, although meron siyang yung common natin na dito na connotation when we hear the words success and failure is ito mostly positive, ito negative, no? Pero in probability, wala tayong notion na ganun, or wala tayong connotation na positive ang success or negative ang failure, kasi it all depends on perspective, no, kung ano mo yung isa-set mo. Okay? So kasi, for example, what is the probability na mamatay yung isang tao? Kunwari ganun. So if that's the case, hindi naman positive ang ano no, ang pagkamatay ng isang tao, pero we label that in that sense, ang success natin is namatay yung taong na yun. Parang ganun. If that makes sense, no? So kailangan natin i-separate to kasi there are certain problems, may mga ganung problems no na kumbaga if you don't distinguish between yung terms na success and failure, parang mahihirapan kayo ma-compute, makakuha ng tamang calculations, no? So kailangan you take the emotions out of it, no? So merong isang problem dito na wait lang. I don't know if I can find it, no. Nandito ata siya. Hindi ko na siya mahanap. Pero may certain problem na kunwari um it was something like ano yung probability na hindi siya na hindi makaka-survive yung isang cancer patient, no, para ganun. Tapos the trouble with nakita ko when students were trying to solve it is that parang dinedesignate nila yung success as naka-recover siya, tapos yung failure as hindi naka-recover, para ganyan. Tapos nung nag-calculate sila, parang nahirapan sila kasi imposible pala. The best way or mahirap ma-solve, the best way to solve it pala is to designate success as yung hindi naka-recover or namatay yung patient, tapos yung failure is naka-recover siya. Which is parang medyo counterintuitive, no? Parang ganun. So later, maybe we will encounter that certain problem na yun. Pero again, ang ano ko lang dito, warning ko lang siguro sa inyo guys na dapat um, again, itong si success and failure has no emotions involved, no? So wala kayong positive or negative na i-attach sa kanya. You simply just you just assign it. It's an arbitrary assignment, no? So success means that it occurs, failure means it does not occur. Okay? So I hope I drove a point there, no? Okay? So let's go with ano muna, the first etong ano. So siguro ito siguro ang ano no, best way na or para ma-remove nyo yung ano, yung emotions out of it. You just do ones and zeros, no? So if you're familiar with coding or yung programming, no, you know that kunwari yung it's basically an on or off switch, no? So either you have a 1, it's on, or you have a 0, it's off. Para ganun. So if you're having trouble with the term success or failure, although in textbooks kasi yun yung terms na ginagamit talaga, no, yung success or failure, then maybe you can use this instead, no? It's either 1 or it's a 0, no? Okay? So ito some of the examples where this probability distributions are useful, no? So for example, yung monitoring ng defective sample, so it's either defective or it's not effective. Sa pharmaceutical na industry, you can have a cure or no cure. So kunwari you're looking at missiles, then you can hit or miss, and etc. etc. Okay? So let's first punta tayo sa yung first to, no, na probability distributions natin. So we have the binomial probability distribution and we have the hypergeometric probability distribution. Okay? So yung first is sa binomial is when the trials are independent of each other, no? So this means that whatever you do sa first yung event na ginawa nyo. So for example, if let's just say I take a card, no, or take a um from a kunwari lang meron akong a box of mga balls, no, kunwari ganyan, or box pa to, a container of balls containing balls. If it's binomial, then if I take this first ball out, before I do another trial, kailangan ko ibalik yung bola na yon. So in that sense, independent yung trials ko. Okay? So from trial 1, trial 2, trial 3, always I start with the same number of balls dito, no? So if in this case, meron tayong 5 balls dito, no? So if I take one out, Kailangan if I do the next trial, ibabalik ko siya para independent yung trial. Now, hypergeometric is when you have the trials are dependent. No? So for example, kung tinanggal ko tong first ball na to, hindi ko siya binalik. Therefore, magkaiba na yung ano no, yung next trial ko kasi yung next trial ko apat na lang yung natira dito. Tama? So if I don't replace that, then I have a hypergeometric function because the trials are now dependent on each other. So siguro ang ano no, ang best way to imagine this is just think about the replacement. No? So are the trials done with replacement or are the trials done without replacement? Kung with replacement siya, then it's binomial. Without replacement, then it's hypergeometric. Okay? So if I do something like a coin toss, kunwari, ito no, may coin ako and I toss that coin. If I do a coin toss several times, so trial 1 ko, first coin toss, trial 2 ko, second that's my second coin toss, etc. etc. Each coin toss na gagawin ko, is it dependent on each other or not dependent? What do you think? Kung dependent, thumbs up. Kung independent, thumbs down. Oh, ba't may nag-party? Nag-party symbol. Sige. Thumbs down. So, may question mark. So, that's okay na. So, pag ganon, kung coin toss, no, it's actually independent. So, tama yung mga nag-thumbs down, no? So, it's independent because kung kunwari, nag-coin toss ka sa, yung first coin toss mo, yung probability mo of getting heads is just 1 out of 2. Tama? Or tails is 1 out of 2. So, yung kumbaga ang sample space dito is still 2 lang naman, no? Every time magko-coin toss ka, 2 pa rin yung ano. So, in that sense, parang may replacement ka sa trials mo. Kasi each trial mo, yung 2 faces, always available siya. Now, let's just say, let's take another example. No? May deck of cards ka, kunwari. You have a deck of cards. Tapos yung deck of cards ko, I have 5 trials. Pili ako ng random card from this standard deck of cards, yung playing cards. Pagka ganon, it makes sense na each time na nagtatanggal ako ng card, nababawasan yung sample space. So from, ilan ba yung deck of cards? Is 13? 13 nga ba? Help me out here, guys. No? Wait lang. 1 to 10, ace to 10, plus jack, queen, king. 13, no? Tama? So 13 yung playing cards. Tapos times 4 gives us 13 for each suit. Thank you, Kenneth. So 13 times 4, that's 56. 56 naman. Hindi, 52? Hindi na ako marunong. Wait lang. Gamitin natin calculator. 13 times 4. 52. So we have 52. We have 52 playing cards, no? So if you have 52 playing cards, tapos nagtanggal ako na, kunwari, sa 5 trials ko, first trial ko, nagtanggal ako, I now only have 51 para sa trial 2. Tapos the next is 50, 50. Tapos and so on and so 49. Dot, dot, dot. Tama? So ibig sabihin nito, pag ganyan, dependent yung bawat trials. Okay? So ganun nyo na lang siya i-imagine. But if for example, if I ask you to take a card, tapos tingnan mo, tapos next trial ko, before I do the next trial, pakibalik yung card sa deck. So pag ganun, trials are independent. So magiging binomial naman siya pag ganun. Okay? So always just remember eto, no? If it's with replacement or done without replacement, or easiest way siguro is look at the sample space. Kung nagbago yung sample space trial to trial, then it's hypergeometric. Kung hindi siya nagbago yung sample space trial to trial, then dapat pagka by the way, pagka dito sa deck of cards, no, pagka usually we mean standard deck of cards, so hindi kasama yung joker, Shane, no. Pero although you're just joking, no? Pero just want to be accurate about it, no? Okay. All right, so ito, binomial distribution is given by this formula, and nobody really memorizes this formula, no? At least in my experience, ako hindi ko na nga minimemorize to, eh. Kasi ginagamit ko na lang Excel. But if you want, you can still memorize this formula. So meron siya for binomial distributions, it's NCX. So that's n combination x multiplied by the probability of success in a single trial raised to the power of x. Tapos the probability of failure in a single trial multiplied by the raised to the power of n minus x. Okay? So again, ito, iano natin, no? Itong success. So this is the probability na on siya, and this is the probability na off siya. Okay? So one thing to note about probability is that yung total probability is always equal to 1. No? Tama? It makes sense, no? Kasi if you take note of all the different ways na that you can do a certain operation or a certain event, then it makes sense na mag-add yung lahat ng events na yun to certainty, no? So magiging certain na talaga. Tama? So for example, if you toss a coin, ano yung probability na heads or tails siya? Then if you count the probability of heads, dapat heads then probability of tails, then dapat 100% dapat 'yun. Tama? Kasi 'yun lang naman ang laman ng elements nung sample space na 'yun, no? Or yung total number of ways doon sa event na 'yun. Okay? So two events I should say. Tama? So dapat one yung ano. So with that said, dapat yung kung ang probability of failure is or probability of success is equal to P, then the probability of failure is just equal to 1 minus P. Tama? Kasi kung, again, this is a discrete na, discrete probability function wherein we only have two discrete elements, no? Yung failure and success. So, kung meron tayong failure, if we take 100% certainty minus that probability of success, probability of success, then we should have the probability of failure. Okay? So, all right. So P is success or on, Q is failure or off. Right? Tapos N is the number of trials. Tapos X is the number of successes in N trials. So ngayon, medyo medyo malabo pa to, pero I think it will make more sense pagka nagano tayo, no? Nag-proceed tayo with an example. Okay? So, but before that, i-distinguish din natin sa hypergeometric function. So you can again also look into this formula, pero again, hindi na to natin ginagamit no kasi usually sa Excel na tayo nagso-solve ng mga ito. So N is the total number of elements, yung capital N. R is the number of successes in those N elements. Tapos N is the number of elements drawn, or we can also regard this as the trials, no? Pwede rin sabihin natin trials siya. Tapos X is the number of successes in the N elements, where X, number of successes in the small N na elements. Okay? Or the small trials. So again, ang suggestion ko, wag nyo nang i-memorize to, no? Gagamitin natin yung Excel, no? Because Excel exists or spreadsheets exist as a tool for us to use. So we use those tools, no? Para mapadali yung buhay natin. Okay? So let's try dito muna. Ito. So suppose we have randomly selected 5 cards without replacement from an ordinary deck. And ito explicitly clue na agad to, no? Without replacement. Therefore, is it hypergeometric or binomial? Without replacement. So the trials become dependent. Tama? So if it's without replacement, hypergeometric tayo. Okay? So from an ordinary deck of playing cards, what is the probability of exactly 2 red cards? So 2 red cards meaning hearts or diamonds. No? So if you're not familiar, yung suits kasi natin is we have we have spades. Spades is a black suit. Tapos meron tayong clubs. Ano yung tsura ng club? How do I draw a club? Ganyan siguro ang club. Club is a black suit as well. Diamonds is a red suit. Tapos yung last suit natin is heart. It's also a red suit. Okay? Right. So let's try to solve this with using Excel. So if we turn back to Excel. So Excel has two, kung if we have yung hypergeometric, start with binomial. Binomial, ang relevant na formula natin is equals binom dot test. Okay? So ito yung ginagamit nating formula, no? Binom dot test. But we can, and siguro pwede kong we can also do this class, no? Para, what I did there was, nilagyan ko ng etong, ano ba tawag dito? Apostrophe. An apostrophe, if you do an apostrophe, you force your, whatever you write next as a text string, no? So, gano'n nag-work sa Excel. So, just in case, so for example, may times kasi sa Excel no, na gusto natin mag-type, kung kunwari, gusto mo lang sabihin na ito yung formula na ginamit ko sa solution nyo. So, pwedeng, ang gawin nyo, instead of doing equals, kasi kapag tinype ko lang yung equals binom.test, ang mangyayari is it will type a formula. Pero kung gusto nyo gawin siyang text string, lagyan nyo lang ng apostrophe siya. This also works with, kunwari, kapag nag-type kasi kayo ng plus, kunwari plus 2. Mangyayari kasi magiging positive 2 siya, no? Or plus 2 minus 3. Magiging negative 1. I-operate niya siya. Or ang Excel will operate it in itself, no? So kumbaga siya na naglagay ng equals na. So if you want to really type plus 2, just do apostrophe plus 2. Magiging positive 2. So it registers it as a text string. So, yan. Although this is not part of the lesson, this is an Excel lesson. Hindi ko sure kung covered to doon sa Excel basics. Pero now you know, no, kung paano. So, we have binom.dist para sa binomial. Tapos sa hypergeometric naman. Hypergeometric, the relevant formula is hypgeom, no? So if you type hypgeom, parang that list. So if you see mga ganito, sometimes you have yung yung mga ganito. So we call this as mga legacy functions, no? Yung mga legacy functions are functions that are more compatible with older machines, no? Lalo na pag Excel 2007, mga ganyan, or earlier versions. So ganito siya. Pero usually we use the yung mga newer versions, ito, yung mga ganito. Although wala namang mali dito sa legacy functions. So they still work. But it's parang for compatibility sake, lalo na pag newer versions. And I think let's do spreadsheet, no. I want to check if si Google Sheets, anong ginagamit ni Google Sheet, no. Let's check. Google Sheet. Ano bang gamit mo? Equals hypgeom. Meron din siya. Dalawa din, no? Meron siyang Google Spreadsheet also has the two available, no? Itong si legacy function, tapos meron din siyang Although I'm not quite sure kung ano yung difference. Pero probably dito sa spreadsheet, pinort lang nila kung ano yung meron si Excel, no? Para mas madaling yung transition from Excel to Google Spreadsheet. Okay? So you can use either. Let's just use the .this, no, kasi mas para consistent tayo. Okay? So yun yung two functions na relevant sa atin. Okay, so let's try the problem na nakalagay, no? Ulit, ano yung stipulation dito? Meron daw tayong standard deck which has 52 cards. Tapos meron tayo 5, magse-select tayo ng 5 cards without replacing them now. So hindi natin ibabalik dun sa deck. So ano yung probability of getting exactly 2 cards? Okay? So dito, we'll have to kailangan natin ilagay lahat ng variables natin. Okay? So again, this is a hypergeometric function. We have n, big N, small n, r, and x, no? Tama ba? Tama. So our big N is ito yung number of total number ng natin, no. No, in this case yung deck of cards. So this is 52. Tapos yung small n is yung number of, in a way, trials na gagawin natin. Tama? So, we have, ang sabi kasi is 5 yung kukunin natin. So, we do 5. N equals 5. Tapos, R natin is the number of successes dun sa, and kailangan natin ano, no? Yung success natin dito, success equals, we get, ilalagay natin siya, success is when we have a red card. Tapos, failure is if we have a black card. Tama? Does that make sense? So again, always we state the success and failures, no? And later I'll show you na pwede actually we can solve the same problem using yung opposite perspective naman, no? What if we do black card instead of red card, yung success and failure natin. Right? So dito, we do N52, 5. R is the number of successes in the total, which is half of the cards are actually red, no? Tama? Kasi half of the cards is, or 1/4 is diamond, 1/4 is hearts. So that makes it half sa cards is actually yung ano natin, yung red cards. Tama? So if success is a red card, then we have 26 successes in the total 52 given. Tapos X naman is kung ano yung number of successes natin doon sa trials natin. So if we have 5 trials, tapos ang sabi daw is doon sa problem is we get 2, tama? What is the probability of getting exactly 2 red cards? So eto class, ano din to, no? Important ditong language dito. So for example, if you do exactly, this says that kailangan ko ng exactly 2 out of the 5 cards, which is different from, for example, if I say, what is the probability of getting, let's say, at least 2 cards. Okay, so if we were to write this down, no, in terms of an equation or in terms of variables, pagka sinabing exactly 2 cards, we are saying na P, the probability of X equals 2. Tapos if we want to say at least 2 cards, then we say probability of X is greater than or equal to 2. Tama? Tapos kung pag sinabi naman natin at most 2 cards, then it's X less than or equal to 2. Tapos meron ding mga cases na more than 2 cards. Meron ding cases na less than 2 cards. Parang ganun. So if you want to do this, usually, ito, we can break this down into further, ano, no? So for example, itong P greater than, X greater than 2, pwede actually siyang, since we have 5 elements, this is actually just equal to the probability of X equals 2 plus probability of X equals 3 plus probability of X equals 4 and the probability of X equals 5. And why do I add the probabilities? It's because essentially this is an OR na ano, no, statement. We call this an OR statement siya. Tama? So it's an OR statement because, di ba, if you think about it, itong X greater than or equal to 2, which is saying at least 2, no? Is saying na pwedeng 2, it could be 2 or 3 or 4 or 5 out of 5. Tama? So all of these are kumbaga or siya na statement. So if it's an or statement, yung sinabi ko kanina, or statements are plus yung gagamitin natin. Pag and statements, multiply yung gagamitin natin. So kaya siya naging ganyan. Right? So balik tayo dun sa ano natin. Let's go back. So ang X natin is we want to get, and balik tayo sa problem, no. Ang sinabi lang naman sa problem is exactly 2. So we are actually just computing for the probability that X equals 2. So nothing more, nothing less. Ito yung pinapahanap sa atin. Okay? So X will be now equal to 2 out of the 5 cards. So with that said, pwede na tayo mag-binom.dist. So I can press tab para ma-select ko yung binom.dist. So number S here is the number of successes. Tama? And if you're not sure, pwede actually pindutin nyo siya. So if you click the binom.dist, maglalabas siya ng help tool dito, no? And makikita nyo siya dito. So makikita nyo na yung number, I know, why am I using binom? Mali pala. I should be using hypgeom, no? Hypgeom.dist. Ang ganyan. Sorry. Equals hypgeom.dist. So, makikita nyo na may sample underscore S, number underscore sample, population underscore S, number underscore pop, tapos cumulative, etc. Pag hindi kayo sure kung what those variables mean, gagawin natin is, pwede nyo i-click actually itong it will give you a hyperlink. Pag kinlik nyo siya, may help tool na lalabas dito. Okay? So, ang importante dito is actually the syntax, no? Kasi ito naman yung gagamitin natin. So, you can also read this, no? It has a background information kung paano niya sinasolve si hypgeom.dist na function. Pero in most cases, ito yung importante sa atin, paano ginagamit yung syntax. Okay? So sample-s, tapos nakalagay na rin pala class no, kung required siya or required or optional na parameter or argument. So dito, ang first argument natin is sample underscore s, and sample underscore s is the number of successes in the sample. Okay? Meaning, number of successes in the trial. So siya yung small x. Okay? So ito, number of sample, this is the size of the sample or ang sample here meaning the trial. So this is our small n. Itong population S is the total number of successes in the population. So dito it's 52, it's the capital N. Tapos yung number underscore pop, number of successes pala, so it's the R value, no? Itong R siya, 26. Tapos yung number, the population size, this is just the total number. Okay? So ang last argument natin, and this is important, is, and pwede tong gamitin natin sa to speed things up kasi si Excel also has a function na pwedeng cumulative or non-cumulative siya. So when we say cumulative, if we tell it to be true, and yes, tama yan, Shay, no? That is the syntax that we will be using. Hypgeom.dist, it's x, first argument n, small n, second argument, third argument r, and capital N, yung last argument. Tapos, pero meron pang isang argument, no? And is a required argument. After n, magta-type pa kayo ng true or false, or pwede ring 1 and 0. No? Depending, I just like to do 1 and 0 no, kasi mas madaling i-type. Pero pwede ring true or false yung ilagay nyo. Okay? So dito sa yung last argument natin is cumulative function, no? So when we say cumulative, it's taking the total of the probability from 0 up to that particular na probability na hinahanap natin. Okay? So kasi probability distribution kasi ito eh. So hinahanap natin from 0 to that probability. Okay? So, importante siya kasi kunwari, ang sinabi dito is at most 2. Then, pwede siyang x equals 0, x equals 1, x equals 2. Tama? So, pagka ganun, mas maganda na gamitin natin na cumulative function siya na from 0 to 2. Okay? So, ito-true natin yung argument na yun. Pero, kunwari, ito, gusto natin na yung exact probability lang sa particular na kung ano yung hinahanap natin na x, then we do false. And in this case, false yung gagawin natin. No? And later, I'll show you kung ano yung cases where we do true or false. So, let's just do dito false ang gagawin natin. So, first, gagawin natin is the sample S. This is the number of successes in the sample, which is ito, no, 2. So, you can also use this, no? Ito, we call this as the dynamic ranges ang tawag dito, no? So, dynamic range meaning na automatic nagbabago yung formula, and automatic yung babago yung formula pagka binago nyo yung certain values, no? So I'm suggesting always to use dynamic ranges, no? Kasi dynamic ranges maganda siya kasi hindi nyo kailangan ulitin lahat ng ginawa nyo, no? So for example, mali pala yung na-type nyo na X. So since hindi ko hinard code si 2 dito, so I could have very well done hard-coded 2 dito, no? So since hindi ko hinard code siya, pwedeng etong X lang babaguhin ko. And this will be very helpful, no? Lalo na pagka sa future na mga lessons natin. There are cases wherein sobrang dami nyo nang nagawa. Tapos, kunwari, mali pala yung in-input nyo na, na value. And kailangan nyo ulitin lahat pagka hinard code nyo siya. So, if you were to do dynamic ranges, mas madaling it just makes your work much more flexible. No? So, if you can, do dynamic ranges. No? And don't hard code your equations. So, ito, I'll do dynamic range. Number of samples is 5. Tama? This is the number of trials, small n. Tapos, next is yung R natin. This is the number of successes in the population. So, number of successes natin or number of red cards is 26 out of 52. This is the number of population, yung total number. Now, yung last argument natin is cumulative or not. So, we don't want it to be cumulative, no, kasi gusto natin x equals 2. So we'll do false. Pwedeng false i-type nyo or just do 0, no. 1 is true, 0 is false. So we can do false. So we have 0.325, which is, if you convert this to a percentage, it gives you 33%. No? So you can also, this is a shortcut, no, pwedeng ganito siya. So sometimes probability, sometimes people like to do probability in terms of percentage. So pwede naman yun. You can present it as how much in terms of a percentage. But sometimes mas okay na din sa mga tao itong 0.325. No? Personally, I just like to do the itong fraction, no, or yung decimal na way of outputting it. Okay? So it's 0.325. Yun yung probability that x is equal to 2. Now let's say gusto natin x equals yung at most naman na case, no? So for example, x is less than or equal to 2. Pare, yan yung gusto natin. Ano yung probability na at most 2 siya? So it could either be 0, 1, or 2. Pagka ganon, if we were to do the brute force method, pwedeng gawin natin is px, kunwari lang hindi nag-exist yung cumulative function. No? So the way we usually do this is, and ito yung dati na ginagawa namin pagka nung manual pa lahat, no? Kukumputin namin na p is equal to p or the probability of x equals 1, probability of x equals 0. Ganyan. So we compute the probability. So I can actually just copy this. No, hindi pala pwede. Hindi pwede naman. Ayan. Now, I'll just do, for this case, no, i-hard code ko na lang. So, 1. Ito is 0. Okay? So, ito yung probability that x is equal to 2, x is equal to 1, and x equal to 0. So, if I do the probability that it is at most x is equal to 2, then that's or, no? It's either 2 or 1 or 0. So, dapat isa-sum ko siya. Tama? So, I could do this one plus ganyan. Pwede ganyan, no? Or easier way to do it is just do sum. So, if you do sum, then you have 0.5 yung probability. So, you have a 50% chance na dapat it's either 0, that it's either 0, 1, or 2, or at most 2 siya. But another way of solving it is to do just the hypergeom function, no? So if you do hypergeom, tapos ang gawin natin, we do the same thing, no? Number of successes is S, ito. Tapos 5, yung trials, population natin is, success in the population is 26, tapos yung total 52. Tapos kung pag ginawa ko siyang true, so it's a cumulative function, so I'm measuring it from 0 to that particular number, you'll notice you'll still get the same result, no? 0.5 pa rin siya. Okay? So, it's up to you guys no, kung paano nyo siya gagamitin. You can do something like this, lalo pag konti lang naman, mas maganda siya. Pero pwede ring ganito. Okay? Tapos, Kenneth asked, and this is a very good question, Kenneth, no? Kunwari gusto mo malaman yung P of X is greater than 2, pwede bang 1 minus P, X is less than or equal to 2? Actually, pwede, no? And there are some cases wherein, kunwari, imposible talaga makuha si P, X is greater than 2. There are some cases that are like that, and therefore you have to rely on these types of relationships. So kailangan may good understanding kayo of probabilities, no, yung probability of success, probability of failure, tapos they all add up to 1. So kailangan gawin niyo siya. So we could actually do it as well, no. So kunwari we do probability of X greater than 2, although si Excel kasi wala siyang function na that measures from the right side, no? Always from the left side siya. So that's saying na yung cumulative niya is always from 0 to that, to a particular na probability distribution, no? Hindi siya nagme-measure from the right side. So kaya always mas maganda kung yung mga less than yung kino-compute nyo tapos mina-minus nyo na lang siya. Pero again, that is also possible. So if you want to get Px is equal to 2, then we do, so let's just do what yung itong sinulat ni Kenneth, no? So if we do Px greater than 2 equal to sa 1 minus P of X greater, less than or equal to 2, which is this one, no? And if we try to compute this brute force, no? Kung gusto natin X is greater than 2, then that's saying X is equal to, and pwede kong isulat na diretso dito, no? X is equal to 3, 4, and 5. Pwede ganyan. Tama? This is the same, they mean the same thing, tama, no? X is greater than 2, that's X is equal to 3, 4, 5 because there are only 5 trials, no? So, dapat ganyan siya. So, if we do probability of, and let me just copy the jump. So, pwedeng ang gawin ko is 3 plus 4 plus 5. Wait lang. Ay, sorry. Naka-equals pala yung kinopy ko. Tanggalin ko yung equals. So that's the probability of 3, probability of 4, probability of 5. Tama? And if I do the equal sign, it gives me, again, the same value, no? So, pwedeng ganyan. So, nasa inyo na how you want to manipulate it. There are some solutions that are easier. So, mas maganda na parang, kumbaga kung gusto niyo maging efficient, try niyo hanapin kung ano yung best way to do things, no? Pero, sometimes, pagka nakakalito na siya, parang hindi niyo, parang ayaw niyo i-take into account. And some students are like this, no? Parang nahihirapan sila i-grasp yung cumulative. Parang masyadong complicated. They just like to do itong brute force, no? Yung x equals 0, x equals 1, x equals 2. Lalo na pagka yung mga binigay naman na trials is small numbers, no? Like for example, ito 5. 5 lang naman. So you can only have x equals 1, 0, 1, 2, 3, 4, 5. That's just 6 calculations. So they just do it like that. No? So no issues. Okay lang naman yun. It's less confusing and and it's less prone to error, no? But if you want to be efficient, you can use the cumulative function, no, para mas konti yung steps na ita-take nyo. Okay? Now, I think I can show you. Let me show you kung binaliktad natin, no? So what if ang ginawa natin, and I'll just copy all of this. Kung magbabago ba siya? If I do, yung success ko is black card and failure ko is red card. So, kumari ganyan yung perspective ko. So, again, wala tayong ano, no? Wala tayong notion kung positive or negative to. Arbitrary lang talaga ang success and failure. So, kung ganito siya, so if the problem is stating na we want to get 2 cards, 2 out of the 5 cards to be red, then that's just like saying na we want the probability that 3 of the red cards, 3 of the cards that we have chosen is black. Tama? Parang ganyan siya. The probability that x equals 3. Because dito sa case na to, binaliktad natin yung success and failure natin. Again, this is arbitrary, no? So, pwedeng yung pag-read nyo ng problem is, okay, success ko is getting the black card. Pwede ang pag-read nyo is success ko is getting the red card. So, it doesn't really matter, no? Some solutions are parang easier done when binaliktad nyo yung success and failures, and some solutions are parang in fact impossible yung makuha pagka hindi nyo binaliktad. So you have to be uh, wary about it, no? So that check nyo na lang. Tapos kung feel nyo hindi nyo na solve siya, kumari nahirapan kayo, parang may kulang sa data, then try to reverse the success and failure, no? Baka mas makuha nyo yung sagot. So in this case, in this particular problem, you can do either way kasi dito, no? You can do red or black yung success or failure. So let's do this. Try natin siya na ang success natin is black cards and failure is red card. So pagka ganyan, it's still the same problem. No? Ang problem pa rin natin is what is the probability of getting exactly 2 cards. So if you want to get exactly 2 red cards, then that's the same as saying that we are getting exactly 3 black cards. Tama? So if you get the probability of 3 black cards, so magbabago na to, no? Ito lang actually yung magbabago. This is 3 kasi we have, wait lang, 3 successes in the 5 trials. Tapos 26 pa rin naman yung black cards out of the 52 na standard deck. And if I expand this, pwede ko expand, no? You'll see na equal lang tong 2 values na to. Wait lang. Yeah. Equal lang siya. So the probability na x is equal to 3 black cards is the same probability that x is equal to 2 red cards. Okay? So I hope I've shown you, no, na the success and failure is arbitrary and depende na lang kung paano nyo gustong i-set up siya. But it is important na before you start, i-state nyo na agad sa simula kung ano yung success nyo, ano yung failure, no, para hindi kayo malilito, no. Alright? So okay tayo doon? I think okay naman siguro tayo doon. Okay? So, tayo natin. Etong Poson naman. Si Poson, Posong, ito yung tamang pronunciation daw. Posong, medyo ano kasi to eh, French daw. So, this NG here is a nasal sound daw siya. Pero, I just like to say Poson, Poson, Poson. Kasi nakakapagod mag-nasal sound. No? Poisson. So the Poisson distribution is useful in describing the number of outcomes occurring in a specific period of time, distance, or volume. So this could be any parameter, no? But it has to be a specific period, no? So this is important because itong mga period na to is we will be using this, no? Ito gagamitin natin when we are trying to do Poisson distribution, no? So it is employed when an average occurrence is statistically known, no, from independent trials. So kumbaga previously established na siya. Okay? So etong si Poisson distribution is usually may telltale signs dito, no, na Poisson yung gagamitin nyo. Kasi usually yung problem is stated that like for example ito, the average number of homes sold by Acme Realty Company. So, ibig sabihin, meron kang parang average na binigay, no? Meron siyang established na average that is already known. So, yun yung clue nyo na parang automatic dapat mag-click sa utak nyo na, okay, Poisson distribution to. Okay? So, the Poisson distribution is stated this way, no? So, meron tayong two parameters or two arguments. This is the X is the number of successes that we want. Tapos while lambda is the known average or the known mean of that particular unit of time, area, volume, etc. Itong given unit na to. It could be anything. And later ipapakita ko kung anong ibig sabihin nito. So ano bang mga examples ito? Like for example, if you want to take ilan yung average na cars na nakikita o average na cars na dumadaan in a particular hour siguro. So for example, from 8 to 10. So that is your period. From 8 to 10, ano yung number of cars na nakikita mo. Pero it doesn't have to be necessarily time, no? So pwede din, kunwari, defects. So kunwari sa semicon industry, ano yung average number of defects sa particular surface area ng isang, kunwari, sa isang chip. So pwedeng ganun. So ang unit mo is a unit of area and you need to kailangan magkaparehas ito, no? Itong X and number of success. So for example, ang tinatanong is the number of uh, number of successes in a given kunwari kung ang hinahanap is number of successes in 30 minutes pero ang binigay na lambda sa iyo is the number of successes in kunwari 1 hour, then you need to adjust, no? Kasi kailangan magkaparehas itong dalawang to. And later papakita ko kung paano yung adjustment na gagawin niyo. Tama? So kailangan ito magkaparehas sila ng period. So hindi magwo-work tong Poisson distribution if itong formula na to if hindi same sila ng period na mini-measure. So for also ito madaling imagine, no, 30 minutes and 1 hour. Pero what if area siya? So yung area dito is per mm squared, I mean mm squared. Tapos ang pinapahanap sa inyo is kunwari cm squared. So you need to adjust this so that magkaparehas sila. Okay? So, eto, let's try to do this. Ito, madali lang. So, the average number of homes that is sold by the Acme Realty Company is 2 homes per day daw. So, what is the probability na on a particular day, which is, in this case, is tomorrow, bukas daw, you can sell exactly 3 homes. So, okay? So, again, babalik tayo sa Excel dito, no? Because Excel also has a function for the Poisson distribution. No? So si Poisson distribution has only 2, no? So it's number of successes and the lambda value, no, which is the average. Okay? So in this particular example, meron tayong 3 tapos 2 yung lambda natin. Tama? And this is the number of homes, no, na isa niya. Okay? So you can use this formula pero again, pwedeng hindi na natin i-memorize siya. We'll just do an Excel or spreadsheet na formula. No? So we are looking for x is equal to 3 given that lambda is equal to 2. So we do equals, if you type Poisson, it has a legacy function as well, no? Itong again, pag nakita niyo yung itong triangle with an arrow, that means that it's a legacy function. So let's just use the current na function na ginagamit natin, which is Poisson.dist. So Poisson.dist. So we use tab para ma-autofill niya. So x here is again yung probability that x equals something. So ito yung observed na gusto natin. Tapos kung ano yung mean is yung lambda, no? Kung ano yung common na nakikita or kung ano yung established na statistical value based on independent trials. So in this case, dalawa daw. Okay, so it's 2. Tapos ito, meron din siyang cumulative and probability mass function. So again, kung cumulative, you either turn this on or off. So it's either true or false or 1 or 0. So dito, we want exactly 3. Tama? Kasi if you look at the problem, exactly yung sinabi. So if it's exactly 3, then we don't use the cumulative distribution function. No? Gagamitin natin is yung mass probability function. So we do 0 kasi false yung argument na to. Okay? So we do x is equal to 0 and gives us 8.180447 or that's 18% and it's the same value here. No? It's 18%. Okay? So that's Poisson. Ano yung papakita ko dito ulit? If for example, ang binigay is let's just say ang binigay dito is 4 homes in 2 days or ang sinabi is let's just say 7 homes per week. Tapos ang tinatanong is what is the probability that they will sell 3 homes tomorrow. So ang gagawin natin, i-adjust natin yung lambda natin. So for example, if we have ano yung sinabi ko? Let's just say so 15 homes per week. So convert natin tong 15 homes per week. We need to convert it to homes per day. Tama? Kasi ang tinatanong is specific day which is tomorrow daw. So if we convert this, 15 divided by 7 15 divided by 7 days gives us 2, tinatamad ako mag-solve. Compute ko na dito. That's 15 divided by 7. Gives us 2.14. So, ito na yung 2.5. Ito, naka-homes per day na to. And ito, pwede na ito yung input natin para mag-match siya dito sa ano natin, no? Sa X value. Okay? So, always remember that class, no? And yun naman siguro, yun yung parating, ano, no? Yung tricky part dito sa Poisson distribution, no? Kasi madali lang yung formula eh, dalawang arguments lang. Ang importante lang is that you identify kung tama ba yung units nyo. Kung nagma-match ba yung x with the lambda. Okay? So yun yung kailangan nyo lang tandaan. Right? So that's for Poisson distribution. We also have properties of probability, which I've mentioned earlier. No, you have the additive rule. If it's P, the probability of A or B occurring. So anytime it's an OR function or it's an OR statement, we add the probabilities. No, so this is actually a term dito. Is this intersection or union? I forgot the exact terms now. Pero ito, probability of A and probability of B. Tapos ima-minus mo yung probability that A and B occurs at the same time. Okay? So that's probability of A plus probability of B minus probability of A and B. Pero again, in MMME14, usually we just simplify it, no, and saying that events A and events B are mutually exclusive, and when they are mutually exclusive, zero yung value na to. If events are mutually exclusive, the probability of A and B is equal to 0. Tapos multiplicative rule is just the probability of A and B. So again, if it's and, it's multiply. So we have probability of A times the probability of B. And usually, this is stated as the probability of B given A. So, ibig sabihin nito parang in simple terms, no? Ito yung probability na mangyayari si B given na nangyari na si A. Because it matters, no? But again, most of the time in MMME14, we treat events as mutually exclusive events, and therefore when they are mutually exclusive events, yung probability of B given A has occurred is just equal to the probability of B because they are mutually exclusive, no? And that goes without saying, no, na if you have a probability of C, so it should be probability of B given A and C has probability of C given A and C has occurred, no? Parang ganun. Pero kung mutually exclusive event sila, P of C lang din to. Okay? So, yun. Right? Tapos you can read more about it in itong notes na to, no? Okay. Anong oras na? 10:43. So we have mukhang hindi na tayo makaka-practice problems, no? So what I'll do is bibigay ko na lang sa inyo to, itong practice problems. And meron naman siyang answers, no? So para pwede kayong mag-practice on your own. Tapos try nyo kung paano nyo makukuha yung answer na to. Okay? Tapos meron naman siya dito, no? Tapos meron namang mga references, and actually yung sa references na to, they actually give you the solution, I think. I think they give you the solution. So, pwede nyo din tingnan kung paano na sinolve, no? Pero, I highly encourage na, again, kasi probability kasi it is more of practice talaga, no? So, try to practice. Try nyo i-solve on your own, and if you can't find the solution, then just go to the page na kung saan siya mahahanap to. Okay? So, ganun na lang. I leave this to you as a do it yourself homework, no? Hindi naman i-check, just so you can practice. Right? So, proceed na lang tayo dito sa continuous probability random variables, no? And we will be proceeding with continuous probability distributions as well. Um, but I want to do one problem. No? Maybe we can do one problem. Hmm, wait lang. Puro para permutations and combinations, ano? Wala pa lang yung etong Poisson and hypergeometric. Hmm, maybe I can show you one. Ano ba magandang ipakita? Wala na ba ibang problem? Sige, okay lang. I was hoping na ipapakita ko yung ano, no, yung yung parang situation wherein nagmamatter yung ano, no, or nakaka-dictate sa solution yung pagpili ng success and failure, no. Pero mukhang wala dito. But anyway, I think I've shown you enough example, no, to really drive the point na yung success and failure is arbitrary, no, na pwede nyo siyang ano. And if still may questions pa kayo, just raise your hand, no, or just speak up sa mic para ma-address ko yun. Okay? So before we proceed to ano, no, itong continuous, which will be the last part of our discussion. Siguro kasi I think you're oversaturated na lang na ngayon. So can we take a siguro 10-minute break? Tapos we'll spend the rest of the time for the ano, no, the last remaining lesson. So let's do 10-minute break. 10:46 na. Balik tayo kahit 10:55. 10:55 na lang. Okay lang? Okay? So let's take a 10-minute break. Tapos I'll see you after 10 minutes. Mm. Hello, 10:55 na, no? So I think we can get back to the lesson. Diyan na ba kayo? Can I have a show of hands? May mga nag-like sa one. Ayan, mukhang madami naman na. So sige, let's assume na nandito na lahat. So welcome back sa lesson, and let's proceed with the last part, no? So let me show my screen again. Okay. So ngayon, we've discussed yung discrete na ano, no, na probability functions. And specifically yung sabi natin ng discrete probability functions is yung particular na inaral natin, yung hypergeometric, binomial, and Poisson, is mostly yung merong success or merong failures, no? Pero in most cases hindi naman ganun parati, no, yung mga probability distributions natin. It's always in a continuous random variable form, no? Like for example, yung you want to know kung ano yung average or if normal ba yung average waiting time na kunwari 30 minutes for a call to Globe hotline. Parang ganun. Di ba usually continuous ano, it's not specific na parang you get the call or you don't get the call. Yung mas interested tayo dun sa continuous variable na yan, no? So in that sense, maganda rin na aralin natin yung continuous random variables, which leads us to the continuous random probability function, no? And actually, if you put this lesson into heart, no, you'll realize na itong continuous random functions or these continuous random variables are the basis for why we do or why we are able to do statistical analysis, no? Kasi when we do statistical analysis, basically we're just saying na this is all based on probability lang, no? So for example, if we, and this is a preview of the next few lessons, no? For example, if we are concluding that something is o kumbaga we are asserting a certain um, hypothesis, what we are actually saying when we do the conclusion is that sobrang unlikely or sobrang liit ng probability na mangyayari yung itong ina-assert natin by chance alone, that this must be the reason kung bakit nakaka-affect siya sa whatever uh, response variable we are trying to look at. Parang gano'n, no? So, this is a gateway of sorts to understanding statistics, no? Yung statistical analysis, itong si continuous probability distribution. And I hope that you gain good appreciation in this. And uh, sana basahin nyo in more detail yung modules. No? And if you want, you can also read ano, no, the references that are listed down dito sa ano, sa probability distribution na to. Okay? So, we can do ito yung pinaka-famous siguro na experiments, no? And maybe you can do this on your own as well, no? Itong si normal distributions. So, in most cases, we always treat things as or if not explicitly stated, no, we treat operations and occurrences as normal distributions, no? And normal distributions, and you can do this experiment on your own, no? If you do a coin flip, kunwari, if you do a coin flip, uh, you'll find out that most of the time you get a 50-50% na ano, no? So this is a distribution of the um if you do 8 flips, no? So for example, ito, this is a coin toss, tapos you do 8 flips, tapos found out that or half of the time heads yung lumalabas, tapos half of the time tails yung lumalabas. Tapos if you do the experiment more times, you'll find out na mas ano, no, kunwari ito, this is 64 flips, you find out na mas kumbaga mas well distributed or mas hindi naman well distributed, mas what's the term, mas mataas yung resolution ng curve natin, no? So if you look at this is a higher resolution curve. So most of the things, if left normally, no, it will almost always follow a normal distribution. So parang yun yung nature ng ano, no, ng mga operations in the real world. Okay? So um the normal distribution looks like this, no? And you've probably heard of the term normal distribution before. Sometimes we call the normal distribution as a bell curve, no? Minsan bell curve, minsan tinatawag din siyang the Gaussian distribution, no? So pwedeng Gaussian. We can call it the bell curve. You can call it simply just as normal distribution. Okay? So the normal distribution, ang some of its features is that, and maybe mas makikita ito. Ito yung features niya, no? If you look at the normal distribution, it is symmetrical along a center axis. And itong center axis is where you have your, I don't know, um, if it's perfectly normal or truly normal, then yung all of your measures of central tendency are located at the center. No? So you have your mu is equal to the mode. Forgot the term for mode. It's ganyan siguro. I don't remember. So hindi ko na lang isusulat ko. Pero yung mean median mode mo is located at the center. No? Yun yung what it means to be a normal distribution, and it's tapering off. So hindi siya nagta-touch sa ano, no, sa x-axis natin. And by the way, this normal distribution, again, it's a distribution, no, meaning it's a this is a probability distribution. So ito yung occurrence, yung nasa y-axis, tapos yung sa x-axis is yung ano natin, parang particular na, kumbaga, x is equal to something, parang ganun. Okay? So you have the highest distribution dun sa mu, yung expected na ano natin, mean. Tapos as you go further away, then you have a lower distribution. So nagte-taper off siya to the left and to the right, and it's symmetric, no? And meron kayong makikita mga terms like this, no? Itong mga sigma process, itong sigma values, and sigma values is the standard deviation, no? So it is found out that if you move away one standard deviation to the left and one standard deviation to the right, then you actually account for 68% of the total possible data. So this is again based on probability lang, no? This is tong areas under the curve. So if you look at the area under the curve, the area under the curve of the area under the normal curve is actually a probability na ano, no, na value. Okay? So the probability that your data set, if your data follows a normal distribution, no, the probability that a particular data falls in between this one plus minus one standard deviation is actually 68.26%. Okay? So that accounts for 68% of your entire data set. Now, if you move two standard deviations, then you are accounting for 95.44%. Okay. And if you move three standard deviations to the left and to the right, then you account for 99.74%, which is almost close to 100%. No? So meaning anything further away from itong nasa tails na talaga, no, itong more than 3 sigmas away from your mu is actually very ano na siya, outliers na sila, kumbaga. So this is exactly the concept of yung mga tinatawag na Six Sigma process, no? So if you go to the industry, you'll probably encounter this term, no? That a process or an operation is Six Sigma, no? So what Six Sigma means is this is a parang quality assurance na ano, no, na terminology. Lalo na when you follow yung ISO 9001. So ISO 9001 is a parang international standard for quality assurance, and usually you'll encounter the term Six Sigma, no? So what Six Sigma is saying is that, kasi di ba ito, this is 3 sigma to the left and 3 sigma to the right. So 3 sigma plus 3 sigma is equal to 6 sigma, and 6 sigma means that you are accounting for 99.74% of the probable variation dun sa process na yun. So parang sinasabi mo na 99.74 is a very high number, no? So parang sinasabi mo na lahat ng variations na pwedeng maka-affect sa process ko, I have already taken into consideration. That is what it means to be a Six Sigma process, no? Okay? So yun yung basis niyan, no? Yung Six Sigma is based on the normal curve. Right? So the area under the normal curve again is a probability, no? So if you have, for example, a normal curve, and let's just assume 2 points, no? So for example, this is your normal curve right here. Tapos you have point A and point B. So if you take the area under these 2 points right here from A to B, then this is the probability that your random variable x for this particular process assumes a value between A and B. So yun yung ibig sabihin niya. And again, for these types of mga mga concepts, mas maganda kung meron tayong example para mas ma-visualize yun kung ano yung ibig sabihin nito. Pero basically, if you have something like looks like this, A to B, yung area under the curve from that particular point, that particular value A to B, that is the probability na si random variable x mo assumes that particular value. Okay? Now I won't go into this anymore and I'll just skip directly into the yung example. This is the probability distribution function. Ito yung if you want to get the exact math of it, then this is what it looks like. Pero usually when we do probability distribution functions, we are just presented with tables, no? The way we did it back then is we relied heavily on tables. So if you look at statistical textbooks, meron usually mga annexes doon na that has a normal distribution table, no? And ginagawa namin is we look up the table tapos tinitingnan namin yung a particular value tapos ano yung associated area under the table. Pero for you guys, hindi nyo na kailangan actually malaman yung table. But maybe I'll show you how to use the tables as well, no? Kasi ang alam ko lumalabas pa rin sa board exams itong mga distribution functions, no? And they don't allow you to use Excel or they don't allow you to use laptops. Therefore, kailangan din in a way kailangan alam nyo pa rin kung paano gumamit ng tables, no, to use this to use the normal distribution. And let me look. Meron bang table? Eto, nandito yung mga tables natin, no? So how to use the table? If you look at this, the z value right here is ito siya, no? This is the z value. So, depending on what the table looks like, usually meron tayong may picture na nakalagay dito, no? And yung picture will tell you kung ano yung exact area na mini-measure niya. So, in this particular case, this is a table that measures 0 to z. So, mini-measure niya yung area under the curve from 0 to z, where 0 is yung pinaka-leftmost tail up to the point z. So if you have, for example, yung z value mo, again, itong z value is the x-axis, no? So kung z value mo is, let's say, 1.3, kunwari. Let's say 1.3. So 1.3 is, the way you measure it is, etong dito sa side na to, is ano ba tawag? The tens value, tapos yung mga hundreds value nandito sa taas. So let's do 1.33 kunwari. Kunwari 1.33 yung z value mo. So we do 1.3. So ito siya. 1.33. So ito. So this is 1.33. So hanapin natin siya dito. Nandito siya. So the area under the curve for a z value of 1.33 from 0 to 1.33. So that's saying yung area under the curve from 0, leftmost curve. And again, asymptomatic. Asymptotic to, no? So this is asymptotic curve. So therefore, parang pa ganyan siya. And yung curve natin, usually pag naka-standard normal distribution siya, no? Is yung mean natin is set at 0. Tapos we do plus yung negative values nandito and positive values nandito. Okay? So, nandiyan siya. So, 1.33. So, parang sinasabi natin, we are trying to find kung ano yung area under the curve from the leftmost na, kumbaga, technically, hindi na to zero, no? If we do something like this is negative infinity na. Okay? So, from negative infinity to 1.33, yung value natin ng area under the curve na yun is 0.98082. So, this is 0.982. Okay? So later, this will all make sense siguro. Right now, parang medyo hindi pa nagme-make sense, ano? Kasi parang wala naman tayong paki dito. But before I proceed with the example, no, let me try to wait lang ah. So again, most things they're normally distributed, no? So we can have, for example, let's just say na ano, no, try to imagine that particular case. Let's just say na meron tayong average na ano, number of failures sa isang particular area ng ng isang operation, no? So for isang operation, meron siyang pinoproduce na, say for example um, a microchip, no, kunwari microchip. Tapos on average, meron tayong nakikitang observed value, kunwari 1.3 defects per mm cube. Kunwari lang, this is just a random value, no? So 1.3 defects per mm cube. Yun yung normally nakikita natin na defects. So imagine na microchip to, no? Kunwari microchip yan. So, if we try to do experiments, no, tapos mineasure natin lahat ng distribution ng ano na to, so we do, and it's normally distributed, we should get a curve that looks like this, no? Parang we should get something like 1.3 dito. Tapos, if we try to plot it, merong standard deviation that's one standard deviation dito, two standard, three standard deviation, and one standard. Ayan. Medyo ganyan yung makikita natin, no? And this standard deviation also has a value, no? Parang based on experiments, pwede nyo actually ma-compute to. So, let's just say, I'll just do standard deviation. So, parang ganyan. For easier, sige, I'll show exact values, no, para mas ma-appreciate nyo siya. So, let's just say ang standard deviation niya is 0.6 kunwari. Something easy to compute na lang. 0.5 para kaya ko yung mental lang. So, 0.5. So, therefore, ito 1.8. This is 2.3. And this is 0.5. 2.8. Tama? So, similarly dito, this is negative, sorry, 0.8. Tama ba? 0.8 plus 0.5. Tama naman. 0.8 tapos 0.3 tapos negative 1.8. Tama, no? It makes sense. So, ganito yung itsura ng distribution nitong parang theoretical example ko, no? Na may microchip daw tapos meron siyang 1.3 defects. Parang ganun. So, etong si distribution na to, we can actually get the probability na kunwari, what is the probability na kunwari ang nakuha ko is 2 defects. Ano ba ang probability na 2 defects yung makukuha ko? So if we get that, ito, this exact value right here will be the probability. Yan yung makukuha ko, 2.3. Ng 2. Na exactly 2 yung distribution. Pero we are more interested in the probability of a range, no? So kung probability of a range, so for example, what is the probability that ang nakuha kong defects is between 1.8 and 2. So kunwari 1.8 and 2, no? So ito siya. So I can get itong 1.8 and 2%. So let's just say ito yung 2, no? 2%. So we can get the probability that the probability that the number of defects I will observe for a particular surface area, itong mm cube, is in between 1.8 and 2 based on what I already know about itong process na to. Kasi over time, I have already established kung ano yung mu ko or yung average mean. Tapos I also establish yung variation ko, which is measured in standard deviation. Okay? So, kaya ko ma-detect yung probability. So, ang importance nito is, for example, if you have 2.8 pataas, 2.8 pataas means that it occurs at a and this is more of ano na to, no? Medyo pumapasok na tayo sa realm of um, parang hypothesis testing and ano and understanding na parang kumbaga parang nag-a-analyze na tayo dito, no? Pero just to preview kung ano yung importance itong standard itong normal distribution eh. If you have kunwari, ang na-observe mo is kunwari, 3 defects. So, based on what we know, eto, this is 99% sabi natin, no? 99.7 ata na compute natin. So, anything greater than that is actually only 0. And since ano to, symmetrical to, kung 99% to, nasa 0.15%. And dito is also 0.15%. And I'm just estimating. 99.7 tama? 0.3 divided by 2 is 0.15%. So there's a 0.15% chance lang na that you will have a value greater than 2.8. Okay? Tama? 0.15 lang percent yung chance na yun, which tells you that hindi yun normal. Parang for parang medyo ano no, counterintuitive kasi bakit hindi normal sir normal distribution nga to eh. Hindi, ang ibig sabihin na hindi normal is that kumbaga given it only has a 0.15% chance of occurring, which tells you na baka may something wrong because it is a very small probability that it occurs randomly. It might be an indicator na that something is wrong with your process. So that is kumbaga siguro a clear appreciation of how we can use this standard tables. Okay? Pero if you think about it, hindi naman pwede na for every process, kunwari ito 1.3, meron tayong process na ganito, gagawa tayo ng distribution stating na gagawa tayo ng mga distributions for all processes. Kunwari 1.3. What if doon sa kabilang kunwari kabilang ano naman, same company, kabilang kunwari different machine that produces different na parang variation of the chip. Tapos ang variation naman nila is 1.9 yung defects per millimeter cube. Tapos yung standard deviation naman, kunwari ang mu niya is 1.9, ang standard deviation is something like 0.6. Kunwari ganyan. So, pangit naman pagka, kunwari, you already know na normally distributed din siya. Kasi yun yung parang general assumption no, that everything is normally distributed. Hindi naman pwede na gagawa kayo ng panibagong graph and panibagong tables for this, no? Na parang, eto, babaguhin ko, gagawin ko 1.9, tapos plus 0.6 is 2.5, tama? So, hindi naman pwedeng gano'n, no? Kasi, kumbaga, there are infinite number of things na pwedeng ano, magawa ng ganitong klaseng tables and figures, and we can't accommodate all of those, no? Knowing that they have the same parang behavior in general, no, na normally distributed sila. So that's why we do what we call as normalization, no? So we normalize yung tawag natin na term. So we normalize these values. So to normalize these values, what normalization does is that for any parang set of data no, ang gagawin natin is we set the mean, yung center line natin to be equal to 0. Tapos each ano dito is equal to 1 standard deviation. 1, 2, papunta dyan. Lahat ng negative values papunta dito. So ganun yun natin siya nino-normalize. Now that we normalize it, we can transform any value, no? So ito 1.3, kaya natin ma-transform into this one. So kaya natin ma-transform to 1.3 into 0, 1.8, yun yung 1. 2.3 is 2 standard deviation, 2.8 is 3 standard deviations. Parang ganun. Kaya natin gawin yun. And that is where your Z transformation comes into play, no? So parang Z score. So this is known as the Z transformation. And to do Z transformation, we just do the X here is your specific value. Ito yung value na gusto mong i-transform. Tapos, Mu here is the observed mean, and sigma here is the uh, standard deviation. So from this one, kung mazi-z transform mo na siya, then now you can plot it using the normal standard deviation. No? Kasi itong normal distribution natin, naka-transform na to, kumbaga yung table na to, in such a way na naka 0, 1, 2, 3 na siya. Parang ganun. 0, 1, 2, 3, negative 1, 2, 3. Parang ganyan. So, if you have z transformed it, then you can place your value anywhere here. So, kunwari, ang na-compute mo is 0.4, kunwari. Then 0.4 is here. And using standard normal tables, which is already normalized, kaya mo na makuha yung probability na. And you don't have to make specific ano. And if you want, you can read this example. This example actually gives you a good idea kung gaano medyo same example siya na binigay ko dito pero mas same example siya dito pero ito mas common, no? So, kumbaga, you are asked to evaluate the customer complaint about the time it took to be serviced in a telephone customer helpline. And kunwari lang na you take 9 minutes. So, is that too long? Too short ba yun? So, how do you measure kung masyado mo matagal yun? So, you can do is, if normal tong no yung procedure na to or normally distributed itong operation na to, then you can look at the process mean and the standard deviation. So from 9 minutes, and if the mean is 7 minutes, so if you z transform this, z is equal to 9 minus 7 over 5. And ito ata yung kinalculate dito. So 9 minus 7 over 5 gives you 0.4. Therefore, it's only 0.4 standard deviations away from the mean. Now, you can look at tables, tapos titingnan mo kung gaano kalaki or gaano kaliit yung percentage, yung probability na mangyari yun. And from there, pwede mo masabi na the smaller, the closer it is to the average, then the more normal it is. Tapos kung kunwari, for this particular case, no? Kunwari, ang nakuha mo is a negative 2.3 na standard, negative 2.3 na z-score, then that is very far from the normal, no? Meaning, this is, yung session mo, sobrang bilis lang. So, pwede mo sabihin na, magaling yung nakausap ko. Parang negative 2.3 standard deviations away ako from the normal. Tapos, pagka nalito ka naman, kumari, plus 5, which is well outside yung 99%, no? Kasi, again, yung nandito is 3 standard deviation yung cutoff natin, no, for 99%. 99.7. So, ito, kung plus 5 yung z-score, no, meaning sobrang layo nun. Parang at least 3 standard deviations away ka na from the process mean. So, we can say na sobrang tagal naman ng session ko na yun, hindi marunong yung yung nakausap ko. Parang gano'n, no? So, that is where z transformation is very helpful. No? Okay? So, ito, again, ito, depending na lang sa table, and I can show you, kumari, Z tables. If I search for Z tables, there are certain Z tables na magkaiba yung treatment niya. Let's look at, for example, itong Z table na to. And always look at sa Z tables, you always look at the figure, no? So for example, itong Z table na to is measured from the center line up to the Z value. So ako personally, I like this type of Z tables, no, because again, symmetrical naman siya. So whatever, kung kunwari, ang hinahanap ko is negative 1.2, then I can just look for positive 1.2, no? Tapos titingnan ko 0 to positive 1.2. So for example, ito 0 to 1.2, ito siya. So ito yung probability from the center line to 1.2. Parang ganun. And since symmetrical siya, ganun din yung itsura niya pagka 0 to negative 1.2. Ito yung standard normal table, no, for from 0 to a particular z value. Okay? So dito sa yung binigay sa module natin follows this type, parang from 0 to z siya, parang ganon. Pag 0 to z, ibig sabihin, no, not 0 to z, negative infinity to z, ibig sabihin yung kinukuha niya yung probability that yung value z is less than or equal to yung capital Z is less than or equal to z. So ibig sabihin yung x mo, yung random variable, is lower than the than the z-score you are computing for. Okay? So always, when you look for z-tables, you can print your own or pwede ding gamitin nyo yung provided. Pwede siguro mag-provide ako sa ng mga z-tables. Um, but always just look for itong mga figures na to. Yeah, these two mean the same thing. Ito lang sinasabi niya is for the negative values kasi to the left of the center line. Ito for positive values since to the right na. But they basically mean from negative infinity to z yung probability. Okay? Meron ding mga ganito na a z table that actually measures from the positive end naman. So ito is from positive infinity to a particular z value. So pagka ganito, ang probability, then yung mini-measure niya is Although, again, di ba, from 0 to 1 lang naman ang probability. So if gusto mo makuha yung left side na to, let's just say for example ito, gusto mo makuha itong side na to, then what you do is, you just do 1 minus whatever probability na nakuha mo to. Okay? So I hope I made that clear, no? So, merong mga pala dito, questions. Merong nagtanong about one-tailed and two-tailed test, si Sharice. So, ito medyo further along the line, pero medyo naman siya, related dito sa natin, no? Distributions natin. So, a one-tailed test indicates that you know exactly where or ano yung particular tail of interest mo. So, for example, if you're testing if this is, kumbaga, I want to know if normal ba na greater than something yung ko. So you know it's a one-tailed test because you want to know if nandito ba siya sa kumbaga outlier ba siya to the right side. So is it greater than ganito, ganyan. So something like, let's say, yield strength. Kasi kung yield strength naman is you want to know if kung lalagpas ba siya sa particular na na yield strength value. So it's always a greater than something type of thing. So pag ganun, it's a one-tailed test, no? Pero if you don't know, for example, wala kayong idea if positive ba siya or kung kumbaga wala kayong idea sa directionality niya, no? So usually two-tailed yung ginagawa natin. So for example, is um the standard deviation of, let's just say, standard deviation ng ano tawag dito? Kunwari, standard deviation ng isang process equal to a certain value. So hindi mo alam kung greater ba yung value na yon sa sa established standard deviation or lower ba siya. So pag in that sense, if you don't know the direction, kung left or right pa siya, then you have to do a two-tailed test. Pero siguro mas ma-appreciate nyo pa siya pag na tayo, no, hypothesis testing na talaga tayo. And yung mga ANOVA and the different statistical analysis. Okay? So I hope that answers your question, Sharice, no? So okay. So proceed tayo. Pero yung gagawin natin, mostly yung ipapakita kayo sa inyo is Excel, no? Spreadsheet yung paggagamitan natin. So, rarely tayo gagamit nitong Z-tables, no? Pero again, you need to learn these things because during board exams, usually lumalabas tong problems na to and wala kayong spreadsheets to help you solve them. So, maganda pa rin na marunong kayo mag-read ng tables. Okay? So, ito, some ways we can solve Z transformation problems. No? All probabilities add to 1% or all probability 1%. No, 100%. I mean, all probabilities add to 1 because again, you have certainty if you take into account all of the possible outcomes. No. So dito, so if you were to solve for the probability that Z is greater than 0.1, then that is also just saying that this is the probability, this is 1 minus the probability of Z is less than 0.1. So technically may ganyan siya, no? Pero since these are very kumbaga minute na yung this is a continuous discrete functions, then we can just leave it as is, no? Na wala nang, in fact, hindi na tayo usually naglalagay ng greater than or equal to or less than or equal to. Kasi kumbaga sobrang pino kasi ng kumbaga distinctions ng mga to. because it's a continuous function. Therefore, kaya hindi na tayo naglalagay ng less than or greater than. Okay? So this is also related to what Kenneth said earlier, no, na parang kung gusto mo malaman yung the probability that x is greater than 2, pwede bang i-compute natin na 1 minus p less than or equal to 2 na lang. Parang ganun. So this is we use that same na analogy dito, no. Although doon sa discrete, no, sobrang kumbaga different yung probability that x is greater than 2 sa probability this is not equal to the probability that x is not equal to 2. Kasi doon, discrete kasi siya. So, kumbaga, ang 0, 1, 2, 3, 4, mga ganyan, sobrang layo ng difference versus continuous functions, continuous na random variables wherein yung distinctions natin is parang 0.0000, mga ganyan. No? So, pagka ganun, okay lang na for continuous, we can say na Px greater than 2 is equal lang din sa x is equal to or greater than 2. For ano no, continuous. Discrete, hindi pwede. Okay? Okay. So sa continuous lang natin siya gagamitin itong mga ganito, yung mga z transform. Okay? So number 1, all things add up. So pwede mong i-minus lang. Tapos ito, since the standard normal distribution is symmetric, then pwede natin makita na yung z is less than 0, negative 0.1 is actually also equal to the probability that z is greater than 0.1. Kasi kung titingnan mo siya, z is greater than 0.1 is to the right, z is less than negative 0.1 is to the left. Tama? And it's symmetrical. This is the same shape. Itong area na to is the same area as this one. Tama? Therefore, dapat equal lang dapat sila. Okay? Tapos, okay na siguro. And ito yung mga pinakita ko na actually ito, no? Itong first three. And itong last is for the normal distribution naman. Okay? So, sa normal distribution, we have two. Itong norm.dist and norm.inf. Pagka dist ang nakalagay, ang hinahanap natin dito is yung kinocompute natin yung area under the curve. Okay? So, if you do norm.dist, parang sinasabi natin, I have this particular z value, ano yung area under the curve? And Excel measures it from negative infinity to z. Okay? So, parang ganito ang treatment ni Excel. To the right. From the left, going to the particular z value. Okay? So, that is for norm.dist. Ito, norm.dist to. Pag gusto naman natin norm.inf, parang, as the name implies, no, inverse to siya. So, norm.inf is saying na I know the probability. Kunwari, alam ko yung area na to. I know this. Kunwari, I know it's 0.05, kunwari. Ano yung associated niya na z value? What is this z value? Knowing this one. So, if you have that information, norm.inf naman gagamitin natin dyan. Hindi norm.dist. Okay? So, let's try as problem, no? Para mas ma-imagine natin. Ay, medyo ano na pala tayo. Kasi overtime na tayo, no? 11:30 na 34 na pala. So, I can give one example para lang mapakita ko sa inyo. Tapos, you can explore all others on your own na lang siguro. Let's do this one. Ano, wait lang. Hanap ko ang pinakamahirap. Mukhang ito na siguro ang pinakamahirap. And maybe I can do just variations of this now. So, meron tayong, and let me just... So, bear with me, guys. Pero if you have classes after this, pwede naman you can leave the session. I'll be recording para ano. So, let's do, ito no. Meron na tayong normal distribution with mu is equal to 300. So, mu 300. ST dev natin, or sigma na lang. Sigma natin is 50. So, find the probability distribution, the probability that x assumes a value greater than 362. So dito class, no, always it's helpful if you try to imagine it first, no. Try nyo yung ganyan. So alam natin na 300 dito, and this is not normalized yet, no? So mu is equal to 300 siya. And each step ko is plus 50. So parang ganyan. 350 to. Ito 400, etc. etc. Tama? Tapos, I want to know kung ito bang 362, ano yung probability na, ito si 362, no? Nandito kasi si 362. Ano yung probability na greater than 362 yung magiging x ko? Which is saying na, what is the probability under this curve? Tama, no? So when you do these types of problems, always very helpful, try to draw it para mas ma-imagine nyo siya. So that's 362. Okay? So what we can do here is we can do a z transform, no? So if we z transform this, and we can do z-score. So z-score natin, the way we do this is yung formula natin which we have is 362 minus 300, and we divide that by the standard deviation. Tama? And we can do, mas maganda kung gawin natin siyang dynamic. So that is our z-score. So our z-score is 1.24. So now I want to know is ano yung z value ni 1.24 greater than 1.24. I mentioned earlier na si Excel kasi measures from negative infinity to the z value, no? So what we can do is actually 1 minus the probability that x is greater than or z is greater than 1.24. Ito yung gusto natin malaman, which is just equal to the probability that z is greater than 1.24. Okay, this means the same thing, no? Tama? Let me just put it there. So if this is the case, then the way we compute it is equal to 1 minus, and sige, isulat ko muna yung norm.dist. So you do norm.dist, tapos x is the mean. You put in the x value, no? So si Excel also has this ano, no, na pwede actually hindi mo na i-z transform. Pwede actually na siya na mag-z transform for you. So if you want to use this, let me do this. So there's two ways you can do this, no? So yung x kasi natin is 362. So we can do is equals norm.dist. So we do x value natin is this 362 right here. The mean is 300. Standard deviation is 50. And we do cumulative, no? Kasi we want to measure itong from 0 to 362. This is untransformed, no? So parang ganyan siya. Norm.dist. So we get 89%. So if you want to take the to the right of 362, then we do 1 minus norm.dist. So that's 10%. Okay, so 10.7%. Okay, so another way of doing it is to use the z transform. No? So if you do z transform, then you can actually use norm.s.dist. So the s here signifies that you are using a standard normal distribution. A standard normal distribution again has a mean equal to 0, tapos standard deviation equals to 1. Okay? So nakasulat naman dito, no. So kung normalized na siya, then you use, so kung and most of the time magno-norm.s.dist tayo, no. Lalo na pagka hypothesis testing na tayo and kahit doon sa confidence interval, usually naka-norm.s na tayo kasi naka-convert to z-score na normalized tables yung ginagamit natin. So if that's the case, ganito yung gagamitin natin. So norm.s.dist, z-score na yung gagamitin natin. Tapos cumulative siya, we measure it from negative infinity to this z-score right here. And if you look at it, it's still the same value, no? 0 to the 1.24. And if you want to compute for the, kung to the right naman yung compute natin, so we do 1 minus itong norm.s.dist. And you'll see na same ng value lang siya. So it depends on you guys kung ano yung, which one you feel is more comfortable. You can do, lalo na pag ganito yung problems, no, you can just do norm.dist, which requires that you know the mu and you know the sigma, or you can do the norm.s.dist, which requires na dapat normalize na siya. Meaning, na z-transform nyo siya. Okay? Nag-make sense na ba? Sorry. Z is, tama ka, ano, no? Less than 1.4, tapos z is equal to z is greater than 1.4. Okay? Thank you, Kenneth, for the, the correction. Okay? So, hopefully, that gives you an idea, no, kung paano siya gamitin. And syempre, mayroon pang mga, ano dito, no, mga complications. If okay lang sa inyo, extend tayo hanggang 11:45 lang. Tapos yun na yung absolute. I just want to give an additional example, no. So for example, let's just use the same distribution para madali. Let's just say na ako naman ngayon gusto ko na malaman ano yung probability na yung x ko assumes a value that is in between, let's just say 240 to 362. So gusto ko malaman ano yung probability na in between siya 240 to 362. Okay? So if you were to draw that, ang itsura niyan is something like, again, it's always helpful if we, if we draw it. So if you do 240, and this is 362, tapos ito 300 siya. And plus yung standard deviation natin is every 50, no? So if you want to draw this, kung 240 to 312, this is saying na ganyan siya. Tama? Ito yung area na gusto natin. So there are multiple ways to solve this, no? So pwedeng actually ang kunin nyo is ito. 0, yung 240 to 300, tapos i-add nyo na lang sa 300 to 362. Tama? Another way of doing it is if you get negative infinity to 362, tapos ima-minus nyo sa negative infinity to 240. So ito, kung kukunin nyo to, tapos minus nyo sa kung ano makuha nyo dito, that also gives you this one, no? Kasi parang ang itsura niya is, this is just equivalent to parang this one, minus this area. Tama? Would you agree that's the same thing, no? Tama? This one is the same as this total area minus this total area. Okay, so you can do the two approaches now, and I'll show you how you solve the two approaches. So again, we can use norm.s.dist or norm.dist. So let's just say we use norm.s.dist na lang, no? Para we will use this z transformation na yun. So if that's the case, then we'll have to add another z-score value, no? This is the z, and usually pwede mo isulat like this, no? If this were handwritten, usually ganito siya sinusulat. So z of 362 is equal to 1.24. Tapos z of 240 is equal to blank. Okay? So pwede natin isulat siya as z 362. Tapos ito z underscore 240. So this is equal to yung 240 minus yung mu divided by standard deviation. So that's our z-score value. Okay? So you have a negative value, which makes sense, no? Kasi to the left siya of the center line. So that's negative 1.2. So now, let's compute for the probability of z is less than negative 1.2. Tama? Probability of z is less than negative 1.2 is equal to norm.s.dist of this z value and cumulative. Cumulative siya. So we do true. Okay? So we have 0.115. Now you do probability of z is greater than, less than, again, less than 1.24. Okay? So that is equal to norm.s.dist z value of 1.24 cumulative true. So ayan siya. So if you want to take the p-value of z negative, so kumbaga in between siya, negative 1.2 in between z and 1.24. Tama? In between. So from 240 to 362 or negative 1.2 to 1.24. Then this is just equal to this one minus this one. So that gives you 0.77%. Okay? So that's how you solve these types of problems. No? Now, I could another way of solving this is, pero again, kasi from the left kasi nagme-measure sa Excel, no? So this is the most efficient way na talaga, no? But if you have tables that measure from the center line up to the 240, then you can do yung 240 to yung negative 1.24 to 0 plus yung 0 to 1.2, no? Kasi wait lang, ini-imagine ko kung may other way ba. Um, sige. We can try to do this, no? If you do 0 to negative 1.2, less than 1.2, then that's just equal to 0.5 minus, sorry. If we try to measure from, kunwari, gusto natin makuha tong, eto lang. So the easiest way to do that, hindi ko na isusulat yung class, no? Hindi ko na isusulat kung ano yung, pero let's just say area 1 na. Area 1 and area 2. Kunwari, ito naman si area 2. This is area 1, area 2. So if you want to do that, another way of doing it is to just do equals 0.5 minus norm.s.this ng negative 1.2 cumulative. So that's 0.38. So that's from dito to dito. Tama? Sorry. From dito to dito. Tapos, also, you can do 0.5. Sorry. We can do, kasi gusto natin measure dito, from dito, itong area 2 na to. So, this is just also equal to norm.s.this ng z, which is 1.24, cumulative, minus 0.5 naman. Tama? Kasi if you want to get area 2, so you get 0.39. So this is 0.38 to. This is 0.39. And if you get the total area equals sum, itong dalawa, then you get the same value, no? So it's the same value. So yun, obviously there are easier, kumbaga this is definitely easier than this one. Pero sometimes baka mahirapan kayo mag-imagine, pwede naman na ganito yung gawin nyo, no? Lalo na pag tables yung ginagamit nyo, kasi there are tables wherein from 0 to siya. So yun, medyo nag-extend tayo, and may questions ba before we end the session? Wala naman. So thank you for joining the session today, and thank you for staying kahit nag-extend tayo. And hopefully you have a good understanding of how to do probability, no? And specifically itong mga different na distributions na ginawa natin, kasi ito yung more important to. Although sa board exams lumalabas, they put emphasis on yung mga simple probability, no? Lalo yung mga cards, dice, cards and dices, and yung mga toss coin, mga gano'n, no? Usually lumalabas talaga yan sa board exam. So importante rin na kumbaga good grasp kayo ng knowledge na yun. Okay? So with that said, end na natin yung session, and thank you everyone for joining in, and sana masarap ulam nyo mamayang lunch. Okay, bye everyone.
Thank you po, sir.
All right.